All right, so we kind of go, or I go in kind of a reverse order to where like we talked about, I go with chapter 3 first and solving them, and then come back to actually graphing quadratics. I think that whenever we solve them first, you have a better understanding of kind of how everything fits in, and it actually could give you 2 extra points on your graph that you can plot at any point. Okay, so you already know a lot of the things that we're going to have as far as the quadratics are concerned, because we've talked about what it means to be like an x-intercept or a solution or the zeros. All of those are the same thing. Okay, whereas whenever you found your solutions or whatever x was, here that's what's going to be called an x-intercept. It's the same exact thing that what we've talked about before. Okay, so whenever we actually have a quadratic, if you notice there's the poster over to the left on the side wall, for those of you that can see it. The shape of the quadratic is what's called a parabola. So what the actual shape that it makes is a parabola. Then the vertex of the parabola is either the highest or the lowest point. Now, it's basically, it looks like a U. It's not a V like the absolute value. It's not a straight line. It has a curve to it. Okay, so don't draw a straight line like we did with absolute value. That's completely different. So because you have the vertex is like the high point of your hill or your low point of like a valley, if you think about it that way. With any parabola, just like with the graph of an absolute value, you could draw what's called an axis of symmetry. That's basically, it's like an imaginary line that's going to go through the center of the parabola. So what that means is I can draw through the vertex, because the vertex is going to be right in the middle. Okay, I can draw an imaginary vertical line. Okay, it will always be a vertical line. And it's like whenever you were making hearts in elementary school, what did you do to make a heart? What did you do with the paper? You fold the paper in half, right? And then you cut it out, and then when you opened it back up again, you had the same thing on each side, right? The axis of symmetry is basically like that fold that you made on the paper, because whatever it looks like on the left is going to be the same thing as far as what it looks like on the right. Then the last thing is that the x-intercepts of a quadratic are where the parabola is going to meet the x-axis. Otherwise, what you were accustomed to, we either call them, what we'll call them are zeros, or you could put solutions. It's basically everything we did before where we could actually solve it. Okay, so what we solved before for the last 2 weeks are the x-intercepts that we're going to have on our graph today, tomorrow, things like that. Now, bless you, with any of these, you have basically 3 forms that you can have these in, and you can still graph them, or you can put them in. Okay, it is completely up to you. I will tell you that vertex form is probably going to be the easiest of any of them to graph. Okay, because it's very similar to whenever we graph the absolute value. Okay, the only thing different from whenever we had absolute value and what you had before, whenever we dealt with absolute value, and you can write this down or not, but whenever we had absolute value, and we graphed it. The only thing that was different was it looked like this here. It was y equals a, the absolute value of x minus h, and then plus k. What's the difference between absolute value in the formula and what we have right here? Is there really anything different? Just one has a squared and one has the two bars around it, right? A is still the same, just like it was before. Okay? H is still how you're going to move left and right, and then K is how you're going to move up and down. So, just like it was before, a couple things that you need to remember. Remember, if A is positive, which way is the graph going to go? Is it going to be pointing up or down? It's going to point up. What if A is negative? Which way is it going to point? If positive is up, which way is negative? Down. Very good. You wouldn't believe it. Then remember, if it was a minus h inside, that we will move right. So then, if it is a plus h inside the parenthesis, which way do you think we'll go? Left. Very good. And then lastly, if it's a minus k, we move down. Okay, that's where it kind of is what it is. So if it's a minus k and we move down, what are we going to do if it's a plus k? Move up. Very good. Whew. You guys are on it today. Have to get out of your system is that whenever a was between 0 and 1, you just automatically treated your a as a slope. Remember, it's not a slope, it's a scale factor. Okay? So whenever you have this, it's going to be a scale factor of what actually happens. Okay? So we'll get to standard form and factored form in just a minute. So we're going to go down and we're going to actually graph vertex form and kind of go from there. So if we have y equals 3 times x plus 2 minus 1. So with any of these, we're going to want to know a few things. Okay? Whenever you have whenever you have vertex form, it's going to look a lot like completing the square, because you have a parenthesis, you have a squared, and then it's the same setup. Okay? So if you ever want to put it in factored form, what you're going to do is you're going to complete the square and go that route. Okay? So if you would rather solve it or graph it in vertex form, then what you're going to need to do is you're going to need to make sure that you've got completing the square kind of down pat. Okay? But instead of actually solving it, you're going to put everything over to one side. So whenever we use vertex form, the one thing you've got to remember, it's going to look a lot like completing the square. In terms of how it looks. Okay? From there, it really has nothing to do with completing the square, but if you want to get it in factored form, that's what you're going to have to be able to do if it's not already looking like this. Okay? So, first things first, as far as what we need to do, is we want to find the vertex of my function. Okay? Or of my parabola. So whenever I find my vertex, what is this plus 2 inside the radical? Is it not the radical, but inside the square? Is it the a, the h, or the k? It's the h, right? So remember that we have a times x minus h squared plus k. So if it's a plus 2, which way are we actually going to go? We're going to go left 2. So we're going to move left 2. We'll do that in a second. Then what about the minus 1 on the outside? What's that going to do? How's that going to move our graph? It's going to go down 1. So if I have left 2, down 1, I'm always going to leave from the origin. So if I'm going to leave from the origin, and I'm going to go left 2, down 1, and I'm going to put my point right there. Okay? My vertex is how I moved left 2 and down 1. What is the actual point that I put on the graph? Negative 2, negative 1, right? So that's my vertex. Whatever I do moving left, right, up or down, whichever it is, okay, once I go left however many, or right however many, or up or down, whatever I have to do in terms of the direction, once I get to my landing spot from my from the origin, that's my vertex. Now, with that, I'm going to have that axis of symmetry. Okay, I'm just going to abbreviate it as AOS. Your axis of symmetry is an imaginary line through your vertex. So if it's an imaginary line through your vertex here, it's always going to be written as x equals. So what is x equal to? What's the x value of my vertex? Negative 2. If you can find the axis of symmetry, you can find the x value of your vertex. If you have the x value of your vertex, you can always find the y value because you have something to plug in. Okay? Oop, that's not what I wanted to do. What would be an easy value to plug in to this equation right up here? 0, right? Not necessarily 0, 0, but just 0. Okay? Because if I pick 0, and I just take the time and I go y equals, and I have 3 times 0 plus 2 squared minus 1. Now, I'm going to show all the steps. You're just probably going to type this into your calculator and go on. That's completely all right. So 0 plus 2 is 2. So I have 3 times 2 squared minus 1. I have 3 times 4 minus 1. So y is equal to 11. Now, the problem here is I don't have 11 on my graph. Okay. Now, on most of yours, if like you picked up the paper, I think it goes to 10. For the most part, you're going to be able to find your spots. But we only go 3, 6, what we actually go to what, 9, 10? So I'm going to put a point right here, kind of where the spot on the L is, because it's going to be one spot above. Now, since I have a spot, 2 spots to the right, and at y equal to 11, what's another value? Or do I have another point now? Yeah, what is it? Huh? Say it again.
Negative 11.
Not negative 11. I still have a point at 11, but where's my x value that it's going to be at? I have a point at 0 that went 2 to the negative 4. Okay, why negative 4? Because it's on the other side, right? So I have a spot that's just going to be 2 places over to the left, and then all I'm going to do is graph my line. Is we need to know what's the domain and what is the range. Okay, from here on out, anytime we introduce new functions, you're going to write the domain and the range. Now, the good thing with a parabola, just like it was with an absolute value function, your domain is always going to be negative infinity to positive infinity. Just like it was with absolute value, what happens if you don't get this one right? Do you remember what you had to do? You forget. Your range then is all dependent on which way it's going. Is it pointing up or is it pointing down? So since it's pointing up, is it going towards positive infinity or negative infinity? Positive infinity. Okay? So your infinity always goes on the end. Okay? Positive infinity is always going to be on the right, negative infinity is always going to be on the left. So since it's going up, what's my lowest y value in terms of my range? -1. Now, -1 is included, so I'm going to put a bracket around it. It's going to be -1 to positive infinity. Okay? It will always be a bracket with your range. Now, if it's pointing down, it's going to be negative infinity and then a bracket on the right side, because your lower number always goes on the left, your bigger number always goes on the right. What am I going to do? What is this -3? Which way is it going to take it? Left, right, up, or down? Right, 3. There's nothing out here, so what happens? It's just 0. I'm not going to go up or down. So then, if I don't go up or down, so then where is my vertex going to be? 3, 0, right? So I'm just going to go over to 3 and 0. And I'm going to plot my point. Now from there, where's my axis of symmetry? Where's that imaginary vertical line going to go? X equals 3. Now, where did we get that number? Yeah, it was the x value of my vertex. So I'm going to have a vertical line, or kind of an imaginary line through the 3. So now when I graph it, again, it's completely up to you. I don't have to always use 0, because sometimes 0 is not going to fit. Okay? Maybe I use 1, maybe I use 2. Okay? Don't want to use 3 because I already did. But it's completely up to you as far as what value you pick. Okay? Even if we pick 0, okay? And if you want to get in the habit of picking 0, as long as you can graph it accordingly, then that's fine. Do that. So then, if I'm going to pick 0, as far as another point on my graph, I'm going to have 1/2 times 0 minus 3 squared, and that's it. So I have -1/2. What's -3 squared? Just 9, right? So 1/2 times 9, which is -9 over 2, you're probably going to see it as -4.5. It's okay if you get a decimal. Now, the one thing I want to make sure is whenever you do that, that you leave it as a fraction. Okay? So where is -4.5? Do you have an exact spot for it? No, but can you graph -4.5? Yeah, where am I going to go? Halfway between -4 and -5, right? So down 4, find about 1/2, and put it right in the middle. So now do I have another spot on my graph? Yeah. Where's it going to be at? Yeah, at 6, and it's going to be right there in the middle. Just give it a little bit of a curve. Now, the one thing we can always find, okay, with any quadratic is if we always use 0, we always can find the y-intercept. Okay? There's always going to be one y-intercept. There may not be an x-intercept, just depending on, because you know you can have imaginary numbers. Okay? But you can, however, have a y-intercept. You will always have a y-intercept at some point. It will always cross the y-axis somewhere. It may be at 172, but it can still cross the y-axis somewhere, okay, in some place. Okay? So whenever it asks for the y-intercept, you can still do that part of it. Okay? Now, I'm going to stop with just the vertex.